investigate the properties of acids by doing a series of experiments. So there'll be 4 different stations set up, and you'll work in pairs, spend 10 to 15 minutes at each station. You won't specifically complete all acids with all chemicals, but we'll combine the results as a class set. But importantly, to get good results, make sure you clean the test tubes and dispose of the chemicals as instructed before moving on. So you're going to investigate pH, the acids reacting with metals, with bases, and with metal carbonates, and if time, you'll look at some solid acids. As with every lab, safety is crucial. Wear goggles and gloves. It may be glass breakage, so handle them carefully. And the chemicals, keep them in the containers and use them as instructed. And the Bunsen burners, don't lean over those because they're a naked flame. So pause to read the chemicals that you're using. There'll be 4 different dilute acids, all 1 molar concentration. And the first of the tests is a pH test. And you're going to put 3 drops of one of the acids on a watch glass, and you're going to test it with blue litmus paper. And you will repeat for the second indicator paper, and then you will repeat again for the different acids with both papers. And then you can test the pH with a pH probe. And as you document your results, give enough detail, including here the appearance of each of the acids. Reaction with metals. So you're going to have a test tube, and here we've got 3 test tubes for 3 investigations, which you'll do with each of the acids. So 1 centimeter depth of the acid in the bottom of the test tube, and then here it shows pea-sized amount of zinc powder from a spatula, 1 centimeter length of magnesium ribbon in the middle test tube, and some copper turnings to put in the last one. And you're going to do them one at a time. You're going to look for bubbling. Remember to record your results carefully, relative sizes of the bubbles and amounts of them. And if you see bubbling, lightly stopper the tube and then test the gas with a lighted splint. So you're going to remove the stopper and bring the flame in very carefully, but don't remove the stopper long before you're going to do the test. Then the third experiment here is with bases. We're going to use powder bases here, copper oxide and iron 3 oxide powders with each of the acids. And to see if a reaction is has taken place, because the powders may colour the solution and you may not see if a reaction has taken place, I'm going to heat it very gently. Point the test tube slightly at an angle but not facing towards any body. Put it into the flame, take it out of the flame, because if you leave it there, it will boil and shoot out. So great care with that. You're only going to warm it, and it says here for 5 seconds. And then you're going to tip it through the filter paper system, and you're going to look at the filtrate. That's the bit that drips through. Has the colour changed? Have you got a new chemical here? And it may just be that you're filtering out the residue of unreacted metal oxide. Observations are critical here. And the last one here with metal carbonates. So got a boiling tube, the wider of the 2 tubes. Put your acid in there, set up the rest of the equipment with the delivery tube under the surface of the lime water in the second test tube. And then just lift the stopper, and you're going to put about a spatula of each of the metal carbonates into the acid, stopper it, and any gas produced will bubble through the lime water. And you'll be doing it with sodium carbonate and with calcium carbonate, but you need fresh lime water each time, and you need a fresh sample of acid each time. And finally, the solid acids, maleic acid, ascorbic acid, and citric acid on watch glasses here, and you're going to put the litmus paper or the universal indicator paper in. Now it says here, did you get the expected results? And what did you expect? So why did you get the expected results or not? And if not expected, what simple thing might you be able to do to get the results you might expect from an acid? And here we have a truncated version of the results table, and you can expand it and give more detail and very thorough observations for each chemical and a description of the reaction before, during, and after. And some of the acids will be the same, some of the reactions might be different. And do the ones that you do and get results from your classmates, but put their initials by them to give them credit for the ones that you didn't do. And then it says name the specific products for each reaction. So the metals, the metal oxides, and the carbonates with the different acids. And some hints are here. The metal plus acid will give a salt and hydrogen. Depends on the metal, depends on the acid, which salt you're going to produce. And then we've got some of the properties of acids, chemical properties, and maybe sourness and corrosiveness, but don't taste these, please, nor discover how corrosive they are either. And testing the gases produce with the metal and the acid if it reacts. Hydrogen pops, very light pop, but you need air present. So when you're writing the equation, what's the hydrogen reacting with? And carbon dioxide, and only carbon dioxide, will turn lime water milky. If we look here, it describes the fact that lime water is calcium hydroxide solution and informs an insoluble carbonate, chalk, calcium carbonate, in the presence of CO2. And write equations for the reactions that took place. So writing equations, you want the chemical names, reactants and products, you want the formulas of each of the chemicals, and then you want to balance the equation so you have the same number and type of reactant atoms and product atoms. And here you can just pause to give yourself the hints of what is being formed, and if you look at the acid, how it helps you work out the name of the salt. And there's a link there. Not sure why it's got that name in the end, but it's definitely a workshop about acid reactions and the equations. And now, how would you investigate bases? how do you think the properties of bases would be compared to acids? And what tests, what experiments could you do to show this? And which reactions would you use that would be similar to the ones you've just done with acids, and which would be different?